Hey guys, this is Professor Janacek. I just want to go over a quick little note about space. If we are in R1 space, sometimes just written as R, this is the set of real numbers. And we can simply look at that as the number line. Positives to the right, negatives to the left. All right, we've seen that one before. What about R2 space? R2 space, you also are probably pretty familiar with. It looks like the XY coordinate system. There is a distance formula that you might be familiar with. D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's what it looks like in R2 space. You can also write the equation of a circle. Circle looks like x minus h parentheses squared plus y minus k parentheses squared equals to r squared. This, of course, is with center at HK, where r is equal to the radius. You could also write a disk. You might not have seen this one, but it's very similar. It's the exact same thing, only we're going to use a less than or equal to instead of an equal to r squared. So that's an R2 space. What about R3 space? What does that look like? Well, there are a couple of different ways of writing it. I'll go ahead and start off with something that kind of looks like the XY plane. But then you've got another one that kind of comes out toward you. So this third line, that diagonal, is really coming out kind of towards us. This is, I'll label this one as the x-axis, the y-axis, and the z-axis. And you can see, of course, that we have the positive going to the right or down or out, whereas the negative goes in front of us, to the left or down or away from us. The distance formula in this case will look very similar. It is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So a point in R3 space has an x, a y, and a z coordinate. We square the difference of the two points, add them all together, take the square root of it, and that's how we find the distance between 2 points. Some equations in R2 space. Instead of a sphere, instead of a circle, we have a sphere. It's like a circle in 3 space. And the equation is x minus a parentheses squared plus y minus b parentheses squared plus z minus c parentheses squared is equal to r squared. Again, r is the radius. And in this case, the center is A, B, C. Remember, we are in 3 space, so we need 3 coordinates in order to determine a point. A ball is sort of like a disc. So the circle is like I'm sorry, a sphere is like a circle, a ball is like a disc. And so we would have this same equation but now we use less than or equal to. So a disk is sort of like a circle where you include the outer edge. I mean, you include everything inside. A circle really is just this bit. A disk is everything filled in. So a sphere is really just the outer bit. A ball is the whole thing, the whole solid thing. Now we can actually have something called a closed ball. It includes the boundary, that outside boundary. And something called an open ball, which does not include the boundary. So you can think of an open ball sort of like an orange without the peeling. The orange itself is the ball. It would be a closed ball. If you peel off that outer boundary, that skin, then you've got an open ball. I hope this helps. Enjoy!